was so excited. I got my notebook out and my pencil bag. I had it like on the table because I thought I was going to learn to read and write that first day. So I was just ready, and then the whole day went by and it was just like introductions and stuff like that. And I was kind of sad that I had to like that. But I was, yeah, because I thought I was going to learn to read and write the first day.
So your expectation is just like, that's it,
Yeah.
you're going to be an adult, you can do all these
I was like, I'm going to go to school and I'm going to learn to read and write, and I was just so excited.
So you can see it just, it maps it, right?
Yeah.
The inflection points, that's the
Yeah.
idea.
Yeah. So, and that's the end of this. So, you know, hopefully, or maybe in a year's time, or your next big event will have a system which will provide feedback, a historical overview as well as, you know, actual real-time evaluation to nudge you towards improving those social interactions. Because I mean, at least I feel like I get a lot out of it. And I think others would enjoy having a personal assistant like that.
So I know, well, why don't we do this? Why don't we have to, is the demo ready to go?
Yeah, I can.
Okay, why don't we pull it up and just show them live sort of how it works. So really the purpose of what we were trying to show you there was really two parts. The first was, you know, we got into some of the, you know, technical weeds, so to speak. We could have just shown you the, you know, just one slide of the video and been like, oh, here you go, guys, right? But we thought that because there might be some people who are interested in doing this, maybe we tried to go into some of the details so that you could take some of what you saw there and do it for your own project. We should also note that we only used 10 people to train that algorithm. That's less than the number of people in this room. So if, you know, ostensibly people in the room got together, you know, you could train an algorithm like that or something equivalent on your own. So what Tuka's doing now is she's got a script, it's written in Python, and you put in your username and your password, okay? And what it does is it's running through, it's doing an IMAP connection. Are you familiar with the IMAP protocol? Anybody in the room familiar with IMAP? Okay, so basically, it's a way that you can collect the mail from your Gmail mailbox or your Yahoo mailbox or whatever, right? So it's just a protocol that you use, a communication protocol to do that. What we've done is we've written some scripts that sort of handles all that nonsense kind of for you. And you can basically go through, and she's going to take the last 1,000 messages from her inbox, and it's going to plot a map of her social network based on those last 1,000 messages. Okay, so that's what the script will do. This first part that she had shown you was meant to say if you were in real time, you wanted to get analytics on your conversations with people using your own data, how could you do it? And this is, you know, for the standard sort of online modus operandi.
So it pretty much shows you like, actually a lot of these mail plugins, if you use any of them, I don't know, maybe Boomerang, I think it's one of them.
Boomerang,
There are others out there that are, you know, providing you a service, mail-related service. They're doing something like this, and I think it's really interesting to show you how fast it's just grabbing all the data from your mailbox. So to, from, body of the text, attachments, whatever, it's grabbing that data. So this is sort of to crystallize how fast it can grab your data.
Yeah. So once it finishes running, I think it'll generate a plot right after that, so we're close.
Those are skipping means.
Skipping, so some of the messages don't have a formal to address. So some mailing lists, for example, they send to something called just undisclosed. That's because if your dean wants to email you, they don't want you to have the email address of everybody else in the school, right? So they have this thing called undisclosed where you can't see what it is, and so for those we just throw them out. We skip them. Okay, so this is
A plot.
This is a plot because you should probably zoom in on the main.
I will. Let me see. So the periphery is kind of like the mailing list. So there's a lot of cleaning that's been running in the transcript and the code, cleaning out mailing lists and stuff like that. And so what is being plotted here is, I don't know how clear that is, but
Yeah, I can take them through some of it. So basically what this is over the last 1,000 messages that Tuka has had, with no input from Tuka, completely automated. That's the key here that you should keep in mind. No input from her. We were able to extract this following social graph. just from only her email address. And what we've done is we've colored the nodes here according to people that we think exist in cliques. They're highly related. So these are cliques that Tuka might be interacting with. You see those yellow dots up at the top? Tuka, why don't you zoom into that thing? And we'll tell you. And then if there are any brave souls, you can come and you can put your email in and you can try it as well. So there's Tuka at MIT. She also has a personal account, Tuka at Gmail. Notice that Tuka at MIT is connected to all of her MIT people in her lab. And you can not only figure out these colored numbers here are the number of messages that have gone between the two parties over the last, I guess, 1,000 messages she has. So not surprisingly, there's a larger volume of messages to Jim Glass, her thesis supervisor, than there are relative to all these other people in the lab, right? So you can see sort of, if you were Google, right, and you just took a probably script that's far more sophisticated than this, you could really easily figure out about Tuka that, here's Tuka's lab, right? Here's her network within her lab. And what you can also do with scripts like this, this is where it gets really powerful and very interesting, is if everybody in this room, for example, downloaded their graphs and you joined them together, you could start to explore the networks of your entire ecosystem, things that you never knew about your entire ecosystem. You could get these transcendent phenomena that you could view. And Google gets to see that with one data email. You get to see a little bit of it, but you can get even more. And you guys, when we release the code, can do that in your own time and merge your data if you prefer. We won't do it here.
Are the numbers between the other email addresses like CC, like the contact between them or something? Because this is technically Tuka's email, right? But like between other.
That's right.
Okay.
Yeah.
Like
So
they
you
CC'd
can
on
know.
each other or something.
Yeah.
Well, you can know, and that's why it gets really powerful the more you can see. So if I email Tuka and I CC everybody in the room, well, you guys know I just emailed Tuka now. So you've observed that part of my social interaction. So if, let's say I was Google and everybody's using Gmail, well, I own the servers. So I can see what everybody's emailing. So this graph is perfect. So the more people that merge their data together, the more closely you can approximate that actual underlying graph, right? So that's the idea. And maybe we should show them one of the other, there's other clusters in here.
Well, if I can, there's probably this one. It's a smaller one.
So there's me, you can see me at MIT.edu. And there's a service that Tuka and I work on called connected.mit.edu. And it figures out that this guy has wanted to start the connected program at his institution in the Netherlands. So it's tied these two together just from the body, right?
And
So actually, let's see if they can guess what one of the other clusters are.
okay.
Maybe you should move, like,
Should I zoom out?
you can zoom in a little bit. Like go to one of the big ones, like the one in the bottom left. So yeah, this is really where the rubber can hit the road. So you don't know, obviously, much about Tuka, other than she's given you a talk. I mean, what would you, if you glanced at this?
These are personal emails?
Family, you got it.
Yeah.
Family. Can you make any guesses about, let's say, who the parents might be? Just by looking at it, just take a guess.
There is the what, the
FR.gov.
If you on the right.
Yeah, you got it. They got it. That's right, yeah, exactly. See, so that's the point. You don't know her, but you could just look at it and
Now
say,
I know your mom.
oh, this is,
an important person.
yeah, it is a very important person. And what do you know now? Now you know, oh, Tuka's close to her family. Just by looking at the plot. You can already figure this out about her. So the question is, if you look at your own plot, what is your plot going to reveal about you when you look at it yourself? Is your family this big network with connections shooting between them? Or is it you have a relationship, a node just with your brother, and then a relationship node just with your aunt, and a relationship node just with your dad, right? So you can learn those things about yourself is kind of the idea that we were trying to get across here.
So the numbers indicate like the frequency of emails or the number of emails. Does the circle, the size of the circle also represent something?
The total amount that they're shooting out.
Oh, I see,
Yeah.
okay.
So the bigger that one is, the more active that node is.
Okay.
It's sending more things out. And again, nodes that exist in a relationship according to an algorithm that we wrote are colored similarly. So those other nodes and these peripheral nodes that are attached here, they actually are also this purple color. But they're just too small that you can't see it very well there.
And see,
That's my personal email. You see, I'm one of those,
but
you
I
know,
don't
those
have,
spider veins, right? You know, just sticking out.
but I don't have access, so obviously Mohammed is using this for many other messages as well. And if I had, if we, you know, we had his data, we could merge it.
You could merge it and you'd see a superstructure that would pop out of that. Yeah. So, yeah, that's the other thing that we thought would be interesting to show you. If any of you have a Gmail account and you want to try, you can come and you can put it in. Well, there's no pressure. You can try it at home if you want. If you don't want to have your data splattered up on the board, but the offer stands.
We work with the school email or not just only email?
Oh, you should. We wrote it for Gmail, just because we were trying to get a posh out of Google. You know, that was the idea, right?
If it's like an email account, an institutional one that's connected to Gmail, does it still work?
Well, that I don't know. I think if it's Gmail servers, it might.
No, I
But
think,
we'd have to try it. I don't know.
I think,
We can try it right now.
yeah, we could.
Yeah. But I can't guarantee you it'll work, right? So whatever script we share with you,
Yeah.
if it doesn't work, you guys could modify it and then, you know.
I mean, there's probably a way to do it. All these emails are using the same protocols. So,
Yeah.
but behind the scenes, they're all working the same way. It's just a matter of.
With Yahoo? Yeah. Yeah, actually, so let's open up the code. I think this is what's going to be most instructive, because I know some people in here were interested in the software, and instead of us just, saying like, okay, let's just throw the software at you, it's going to be better if we open up the software, because some of you have programming background. We'll try to step you through the logic a little bit, so that when we then share it with the participants in the workshop, you can be like, oh, I remember what they were talking about here. Okay, I got it. Let me do this or do that. Okay, so maybe we can open up the software and show them the basic idea.
That's what I thought that was.
I use it with Gmail, so I don't know. I will try it for you.